Yes, dear students. So right now only 2 students have arrived. I'm just waiting for 3, 4 more to come, and then I will start BITSAT chemistry booster quiz. I hope your JEE main exams are going, so you are already tired, but still, I just want to see that. Okay, only 2 have arrived. Just 2, 3 more students should come, and I will start the questions. Hello, everybody. Now I'm going to start. Going to post the question. Be very fast and solve the question, right? So the first question is, I hope the screen is visible to everyone. And the first question is, which of the following will decolorize alkaline K-amino4 solution? Fast, you have just 60 seconds to answer the question. 4 options here. The first one is C3H8, second is CH4, third is CCl4, and the fourth is C2H4. So fast, which option is correct? Let me know. Either it is A or B or C or D. Let me know fast. You can type the answers on the comment section. Very good, Bachna. Let me see one more student to post the answer. I think he or she doesn't know the question answer. Next, let me pose the next question, and it is, when propyne is treated with aqueous sulfuric acid, that is H2SO4, in the presence of HgSO4, the major product is either propanol, either propyl hydrogen sulfate, acetone, propanol. So find out faster which one it is. Yes, fast. Wow, very good. Okay. You all are doing very good now. Let me pose the next question. The next question is, the compound 1,2-butadiene has these 4 options. Is it only sp hybridized carbon atoms, or it is only sp2 hybridized carbon atoms, or it is sp, or it is both sp and sp2 hybridized carbon atoms, or it is the 4th option? Let me see who does it very fast. Okay. Think nicely, think wisely, and think also smartly. Because in BITSAT, you have to be very, very fast with smart answers. Yes, very good. Everyone is correct. Everybody is doing good. The answer is D. Right. Next question. The question is very simple. I think everybody would be doing it correct. The question is Bayer's reagent is alkaline permanganate solution, or acidified permanganate solution, or the neutral permanganate solution, or the aqueous bromine solution. Fast, fast, fast. This is very easy question. Okay, only one has answered. Only Vachna has answered. Now Arihant, very good. Mm-hmm. Yes, Hard, you also try. Okay, very good. So all of you are correct. The answer is A. So next question here it is. Are you ready with the answers? Okay. Hmm. I think you all need to think again. The question is, which of the following compounds does not dissolve in concentrated sulfuric acid even on warming? Right? So I must tell you that now Vachna is correct. Others have given the AAAA option, that is not okay because saturated compounds do not react with sulfuric acid even on warming. Okay, so the answer is C and it is hexane. Very good. Next question. The highest boiling point is expected for which one of the following? Is it isobutane, or it is normal octane, or it is 2,2,3,3 tetramethylbutane, or is it normal butane? Okay, Vachna has written B. Good. So as you all know that the highest boiling point is expected for normal octane. Why is it? Because in the alkanes, the boiling point increases with increase in the molecular mass due to increase in the van der Waals forces. Very good. Arihant is also correct. So also in the isomeric alkanes, the boiling point of the branched alkanes is less because with branching, the molecule acquires a more spherical type of shape, and this gives less surface area, and this decreases the van der Waals forces. Okay, so the next question is this one. Okay, let me see. So 1 chlorobutane on reaction with alcoholic potash gives what? You both are telling about 1 butanol, which I do not think, and somehow Vachna tried it again and she tried very well, and she is correct. The answer is A, and that is butyl-1A. You know why? Because here no rearrangement takes place because the carbocation is not formed. Okay. So I don't know why Arihant you selected the B option. The correct option is A. Okay. So the next question is this one. The number of structural and configurational isomers of a bromo compound, that is C5H9Br, formed by the addition of H.Br to pentyne respectively are. What are those things? You know. Let me see who writes this fast. Try fast, fast. Yes, you have to try very fast. Yes, nobody is answering. Vachna, Harth, Arihant, everybody try fast, fast. You just draw that bromo compound and try to find out the isomers of that bromo compound that is formed by the addition of HBr to pen to ion. So you have to find the number of structural isomers. Okay, I think I need to answer this question. The correct answer is B. Okay, now next question. You have to try the explanation by yourself because each of the two products shows geometrical isomerism and the total products becomes 4. Okay, so you have two products, that's why 2, that is structural, and the configurational isomer is 4 because there are geometrical isomerism also possible. Next question is, when cyclohexane is poured on water, it floats because cyclohexane is in boat form, cyclohexane is in chair form, cyclohexane is in ground form, cyclohexane is less than water. So what is the reason that when it is poured on water, it floats? Yes, it's very easy. The one who knows the concept of density can understand why things float in water. Yes, Vachna is correct. And so I'm not going to wait for other people because it was so easy and you took so much time to answer. Fine, next question. acidic hydrogen is present in ethyne, ethene, benzene, or ethane? Very good, Arihant. You also tried well. Let me see who will answer this question first. Very good, Harth. What about others? Why taking much time? This is so easy. It's about the acidic hydrogen. And you know that terminal alkynes have acidic hydrogen. Why? Because hydrogen is attached to a more electronegative sp hybridized carbon. Yes, Vachna is also correct. So let me share the next question. The next question is normal propyl bromide on treatment with, I think, I asked this question once again. Anyways, write the answer. Normal propyl bromide on treatment with ethanolic potash gives what? Let me see who is answering for the first. I'm waiting for the answers. The question is so simple. It's about normal propyl bromide on treatment with ethanolic potash. It will give something that you all know. But what it will give, that you have to find out. This is haloalkane. Treatment with ethanolic KOH, it gives something. Will it give alkane or will give alkene? Yes, Arihan, you have done it very, very correct. And the answer is propene. Very good. So the next question is this one. Oh, sorry. Wait. Next question is this one. In the compound that is given there, CH2 double bond CH. So this is the question. CH2 double bond CH, single bond CH2, again a single bond CH2, again a single bond, and you have C triple bond CH. So the C2 C3 bond is of which type? Wow, very good. Others also try fast because the fastness is the major criteria for BITS Pilani. Okay. So next question here now is, which of the following alkenes will react fastest with H2 under catalytic hydrogenation condition? Okay, I'm repeating the question once again. Which one of the following alkenes will react fastest with H2, that's hydrogen, under catalytic hydrogenation condition? think fast, think smart, also think logically. You have to just figure out about the relative rate of hydrogenation of alkenes. What happens to the hydrogenation of alkenes with the increase in the steric hindrance? I hope everybody of you knows about steric hindrance. And then, so you have to find out which of the following alkanes will react fastest with H2. Figure out which is having the most steric hindrance. Because Vachna, you are not correct. So Arihant, hard, everybody try. It's not D. You have to find which one is having the least steric hindrance. So it will react the fastest. D is having four R groups. So it is having the maximum steric hindrance. And when steric hindrance is there, the compound cannot react so fast with H2. I have already given so many hints. Okay. Compound D is having four R's. Okay, Vachna. So it is having maximum steric hindrance. And the question is about the fastness of the reactant. The reactant has to have least steric hindrance. So you have to just see the number of R's least in the compound. And also look about the cis and trans thing. Okay, let me tell the answer is A. Why? Because it is having the least steric hindrance. It's not B, it's A, and Arihant, very good. Because it's all about fastness of the reactant. If you have so many things around to create hindrance to the compound to react, it won't react so fast, and that's why it's the A. Next question here is, in the presence of okay, the question is, in the presence of peroxide, hydrogen chloride and hydrogen iodide do not give anti-Markovnikov addition to the alkenes because both are highly ionic. One of them is oxidizing, other is reducing. One of the steps is endothermic in both the cases. All the steps are exothermic in both the cases. So what is the correct option here to find out why hydrogen chloride and hydrogen iodide, they do not give the anti-Markovnikov addition to alkenes in the presence of peroxide. And this effect is very well known as the peroxide effect. Also, a name is there that is called Kharash effect. Fast, I'm waiting. Yes, others also try fast because this is just a theoretical question. There is no calculation involved. It is like the student who knows about the peroxide effect will mark it within a seconds. And yes, Vachna is correct. The answer is endothermic. That means one of the steps is endothermic. In the presence of organic peroxides, the addition of the unsymmetrical compounds to the unsymmetrical alkenes, it takes place in a manner opposite to the Markovnikov rule. So the more negative part goes to the carbon atom, having more number of hydrogen atoms. And addition of halogen acids to alkenes is an example of electrophilic addition, but the addition of hydrogen bromide by the peroxide effect is an example of free radical addition. So what happens in the presence of the peroxide, HCl and Hi, they do not give the anti-Markovnikov addition to alkenes because of one of the steps is endothermic in both the cases, and the main steps of the free radical addition in case of peroxide effects happens. Okay, so next question is, the question is the products obtained via oxymercuration, that is HgSO4 plus H2SO4 of 1-butene would be either of these. Yes, fast, fast. These are very typical type of questions. Already you are preparing for JEE main, so so many times you must have seen these type of questions. This oxymercuration, hydrogen peroxide reaction, and all. These very typical questions every time these are asked. So, what happens when one butane reacts with HgSO4 and SgSO4? What is that product formed via oxymercuration? Okay, Ananya has now joined and she says A is the option that has to be correct. But is that true? Vachna also says A is the option that has to be correct. I'm waiting for Arihant's choice. Let me see whether Arihant is right or not, or he's trying or not. Hmm. Can't wait more. And yes, the correct answer is A. Very good, Vachna and Ananya. Next question is, so the next question is, how many chiral compounds are possible on monochlorination of 2-methyl butane? Either it could be 2, 4, 6, or 8. So, how many chiral compounds are possible on monochlorination of 2-methyl butane? Okay, others also try fast. Yes, Ananya, hard. The question is, how many chiral compounds are possible on monochlorination of 2-methyl butane? So when you Okay, so here again, Arihant is correct. There are, two chiral compounds here, which means actually there are four optically active compounds. And I think, Vachna, I have already told you once, like chiral compounds means having optically active property. So here, four optical active compounds are generated. That's why it says that there are four chiral compounds that are possible by the monochlorination, because D and L forms are very much different from each other. That's why even if it is giving two compounds, but actually it gives four optical compounds. So Arihant is correct. Ananya, you also were correct. Just think in a way where, like, uh, how many optically active compounds are generated, because chiral compounds is equivalent to an optically active compound. That's why the question is a tricky question. And I think this type of question, once again, I had asked about the number of structures being formed as a chiral products. So it would be four, and that the option is B. So now I am sharing the next question. And the next question is again a theoretical question. It says that the nodal plane in the pi bond of ethene is located in the molecular plane, a plane parallel to the molecular plane, a plane perpendicular to the molecular plane, which bisects the carbon-carbon sigma bond at right angle, a plane perpendicular to the molecular plane which contains the carbon-carbon sigma bond. So just think fast, think the logics, think about the theory you have learned, think about the concepts you have understood, and then select the right option. I am not getting the answer of hard. I think he is not responding more. So I'm repeating the question once again. The nodal plane in the pi bond of ethene is located in the molecular plane, a plane parallel to the molecular plane, a plane perpendicular to the molecular plane, which bisects the carbon-carbon sigma bond at the right angle, a plane perpendicular to the molecular plane, which contains the carbon-carbon sigma bond. Okay, Vachna has tried. Now next, Ananya, Arihant, Harth. Yes, I think now I should tell the answer. Only Vachna has tried it, and she has tried very, very correct. And the answer is the molecular plane. Because the molecular plane does not have the pi electron density, so it has the nodal plane. Okay. Now I'm sharing the next question. And today we will just do one more question after this one. Because many of the students are still preparing for JE main. That's why I just thought to give only 20 questions today, and I think tomorrow morning again we can connect. I'll share the time again when we will have this quiz session. So try fast. Consider the following reaction. It reacts with the bromine radical, gives something plus H.Br. So you have to just find out the structure of the major product, something that is being formed there. Vachna is very actively participating. Very good, Vachna. Others also try fast so that we can come to a conclusion. Good, good. You kept quiet for some time, hard. I think you were lost somewhere, or maybe not attentive about the questions because. Okay, so all those three B options are very, very correct. Very good that you all know how to solve this one because the product must be stable product, and when it's a tertiary free radical, it's very much stable, and so that is B option. Very good. So the last question today is, now I'm going to share the last question. Just a second. Yeah. This one is again, this is again a easy question that will come to the screen. Okay, Hard, it's okay. You had some network issues. Fine. That's why I thought of giving just 20 questions today. And from tomorrow, we will do at least 60 questions in an hour. 1 minute, one question. That is the maximum time to be given in chemistry questions. Because you have to work more on the physics numericals and the maths numericals. So for chemistry, 1 minute, one question is the maximum. But I would say try to do 40 seconds, one question. So this is the last question for the day, and I want answer from everybody that is online. I think we have 6 participants, so there must be 6 answers coming up. The question is, identify a reagent from the following list which can easily distinguish between 1 butene and 2 butene. This is a very common, commonly asked question. Yes, I got 3 people answers. Okay, now 4 people have answered. Okay, fine. So finally, this is the last question, and you all are correct, and this is very good. You are really, learning with conceptuals and understanding things so nicely. And also, since I am pushing hard to you to do the questions, very fast, you have to think logically, think smartly, and act very actively. Okay. So now it's like. Just winding up this session, and I will share the time again. It was really, I just thought to do on the YouTube because this is where internet issues will not uh, hurdle will not be hurdling you for solving the answers. I just thought, on the Teams you have to first download the answer question and then you solve it. So better. Okay, I'll share the time and bye bye. All the best. Study hard and very smart. Okay, bye.